Okay, so welcome everyone. Today we're going to be walking through the first topic of GCSE maths, and that is types of numbers. So there are three types of numbers that you need to know. The first type of number is our integers. The second type of number you need to know is our rational numbers. And the third type of number you need to know is the irrational numbers. So today we're going to break down these three types of numbers, and by the end of the video you should have a clear understanding of what these three numbers are. So first off, we're going to take a look at what integers are. Integers are whole numbers, such as 1, 2, 3, and so on. This also includes any negative whole numbers, such as -1, -2, -3, and so on. The final number that's included in our integers is the number 0. 0 stands out as it essentially has no real value, and it's in a different group to our positive and negative numbers, but we need to remember that 0 is also included as an integer. So let's move on to our second type of number, the rational number. Rational numbers have three main numbers that are categorized as rational. The first type is fractions. Fractions are our first type of rational number. Let's take a look at an example of a fraction. We're going to look at the number 3/4. So if I have a nice big slice of pizza and I divide it into 4 parts, I have now divided it into 4 using my bottom number. But to finish off, to represent this pizza using my fraction, I need to now take 3 parts on top here. So if I take 1, 2, 3 of my 4 slices of pizza, I have taken 3/4 of a pizza. And that's how fractions work as rational numbers. The second type of rational number is the finite decimal. If I'm to turn my 3/4 into a finite decimal, it would be represented as 0.75. 0.75 is an example of a finite decimal because it has a limited number of decimal points. So if I look, it only has 1 and 2. 2 decimal points. But a finite decimal can have any number of decimal points that's a limited number. So I could have a decimal with 1,000,000 decimal points, but it's not an infinite number of decimal points, so it's a finite decimal. And that means that I can represent it as a fraction, and it's a rational number. My final type of rational number is the recurring number. A good example of a recurring number is the number 1/3. If I'm to represent 1/3 as a decimal, I would have to do 0.3333, and these threes would go on forever. So unless I have an infinite amount of time, I'm never going to be able to represent this number the same way I did my finite decimal. But the way I can represent this very quickly is by using a quick symbol like this. I draw one of the threes out and I put a dot above the 3. And this dot shows that this 3 will recur forever. But what if I have a number that has a recurring pattern, but the recurring symbol is different and more than one number? So if I have a number that's going 1, 2, 3, 1, 2, 3, 1, 2, 3 forever, again, I can represent it using this symbol, but I need to use it slightly differently. Instead, I will do 0.123, and then I put a dot over the first number in the recurring sequence and a dot over the last number in the recurring sequence. And this also represents that 1, 2, 3 is going to be a recurring symbol. So finally, what do I have? A recurring number that goes 0.12333, and my 3's continue forever. The way I can represent this is using the same symbol like so, 0.123 with a dot over the 3. And so the 1 and 2 don't have a dot, so that shows that they're not recurring, but the 3 has a dot that shows that the 3 is the part that will continue forever. So now let's have a look at our final type of number, the irrational number. Irrational numbers have an infinite number of decimal points, and all of the decimal points are random. This means that our number goes on for an infinite number of points, and you cannot predict what the next point will be unless you figure it out. A good example of an irrational number is pi. Pi can also be represented with this symbol. If we look at the first few points of pi, it looks a little bit like this. 3.141559. And the digits of pi go on an infinite number of times, and we cannot predict what the next digit of pi is. They go in a random order. And this means that whenever we're using our irrational numbers, we can't use the real value for the number because we do not actually have the real full value of the number since it goes on forever. So whenever we use irrational numbers, we have to use an estimate of the number. So let's recap our three types of number. Our first type of number is the integer. Integers are whole numbers that are either positive, negative, or equal to 0. Our second type of number is the rational number. Rational numbers can either be represented as fractions, finite decimals, or recurring decimals. Our last type of number is the irrational number. Irrational numbers have an infinite number of random decimal points. This means that we can only estimate the value of them, and when we're using them in our equations or mathematics, we have to use a rounded up estimated version of them. Please like and subscribe if you like the video. And if you're interested in our one-to-one personal tutoring, you can click the link in the description and fill out our form to book a free introductory session. See you next time.